Let's look at just how to take an inequality that already has been solved, just looking at the solution set, and how we can put that onto a number line. Let's say we have the inequality x is greater than 3. So like we talked about when we make our number lines, we're going to put that 3 in the middle. So I can start here with 3 and then decide what I want to count by. I want to count by ones. So then that's going to be 4 here and then 2 to the left. So now I've counted by ones. When we have it greater than or less than, where it does not have the line underneath, that means the or equal to part, then when we make our circle, we're going to leave it an open circle. That means that the answers can come right up to, but not actually be equal to that 3. And I want all values for x that are greater than. So that's what this, how this is read. All values for x that are greater than 3. So then the values that are greater than 3, we can check. 2 is not greater than 3. 4 is greater than 3, so that helps me decide I need to shade in this direction. And we add an arrow at the end to show that it goes on that direction forever. Let's look at another example with some negatives. So let's say we have x is less than or equal to -4. So that I want that -4 in the center. Decide what I want to count by. I'm going to count by ones again. 1 to the right will be -3. And 1 to the left is -5. Remember what we talked about with the negative numbers on the number line. Think of it as counting backwards when we're doing negatives, so that might help. Unlike the first one, this one has that line underneath, so it's not just less than, but it's less than or equal to, which means our answer can be exactly -4. So I'm going to fill in that circle, because the answer can be exactly -4, but it's also values for x that are less than or equal to. And then the numbers that are less than are the -5, -6, and so on. So the numbers to the left are less than. And again, when I put the arrows, we know it goes forever in that direction. One trick that works most times is we can use this inequality like an arrow. So this faces to the right, I shaded to the right. This one faces to the left, I shaded to the left. Here's an example, though, where this does not work out. Let's say we have 10 is less than or equal to x. So what's different this time is that the variable is on the other side. So we actually need to be able to read these inequalities kind of in a way forwards and backwards. So it says 10 is less than or equal to x. If I read it backwards, I start with the x. X is, and then I see the bigger than side first, so that's greater than or equal to. Or I can rewrite this. So this is the same thing as saying x is greater than or equal to 10. And I can tell these are the same things because I notice here that the bigger side faces the x, and still here the bigger side faces the x. The point side faces the 10, the point side faces the 10. So that's how I can check and make sure they're actually equivalent. Now, as long as the variable is on the left, now I can follow this like an arrow and it's going to tell me I'm going to shade to the right. So let's graph this one. So x is greater than or equal to 10. I'll rewrite that so we can see it easier. X is greater than or equal to 10. So I'm going to put my 10 in the middle. I'm going to count by ones. So that's 11. That's 9. Because it does have the equal to part, then I want to fill in that circle. And then greater than, or I can follow the arrow. I'm going to go to the right. So again, just because it's originally said less than does not mean we're going to shade to the left. That trick only works if the variable is on the left-hand side. So you can either read it backwards and read this way, x is greater than or equal to 10, or rewrite the inequality so the variable is on the left. And let's try one more with a fraction. -1/2 is greater than x. So I could leave it like this, but if I want to be able to check and use this like an arrow, then I'm going to want to rewrite this. So I'm going to say x is, the small side points towards the x, so make sure the small side still points towards the x. So x is less than -1/2. So I'm going to put my -1/2 in the middle. 1 to the right will be 0/2. 0 over 2 is just 0. And then to the left would be negative 2 over 2, which is really just negative 1. So I'm actually counting by halves, a half bigger and a half smaller. And then when I make my line, it does not have the equal to part, so I want to leave an open circle. That means it can get really close to negative 1/2, but not actually be equal to negative 1/2. And values for x that are less than. So these values to the left are less than. So some common errors, again, be careful with how you are numbering your negatives. And you cannot always treat this like an arrow. That only works when the variable is on the left, like in this example here. So if you need to, do what we did here and flip those inequalities around to put the variable on the left, then you can follow the inequality like an arrow.